Hey guys, it's Lydia. So, my project is on airplane contribution to climate change. So, let's get started. Airplane fuel. Airplane fuel currently has 11% of the United States CO2 emissions. Airplane emissions from the United States are responsible for half the CO2 in the atmosphere, along with emissions of NOx and water vapor, which contributes to the warming impact of aircraft emissions. How does this affect the atmosphere? We all wonder. With all of these pollutants in the air, it causes the upper layers of the Earth's atmosphere to warm up more than they are used to which then puts stress on the ozone layer that can cause holes to form in the ozone layer, which can make us more vulnerable to UV rays from the sun. How much of each pollutant is produced per year? CO2. For every mile, 53 pounds of CO2 is produced. For NOx and SOx, there's no specific amount, but high amounts are produced per airplane ride. Other facts. On September 28, 2010, a section by MIT News was published saying that there are 8,000 deaths on the ground from airplane emissions alone. They said that a lot of travel by planes happens in the northern hemisphere, where the jet stream is, which then sends the pollution from plane to other continents. That is why they believe that there have been a lot of deaths in India as well as China. New planes called Airbus A380 and Boeing 787 use less than 3 liters of jet fuel for every 100 passengers. That lessens the amount of pollution going into the air each year. It is said the airplanes can generate 43 gigatons of pollution that can produce more climate change by 2050. That's not that far away, even though it seems like forever, it'll get here in no time. How can this affect human health? Studies say that NOx and SOx are so tiny, it can be smaller than the width of human hair, that when we breathe it in, it's possible to inhale them, and they can get caught or wedged in our lungs, which could then possibly enter the bloodstream. Side effects from NOx are nausea, or throwing up, or feeling sick to your stomach. Or you can become oxygen deprived, so you basically feel like you're not getting enough oxygen, and it could be hard to breathe at times. And or you can have interference with folic acid in your body. Folic acid is a vitamin in the B category found in green vegetables, the liver, or the kidney. The side effects for SOx are damage to the respiratory system. It can cause skin burns or eye damage if too much of it is in the air or if you have direct contact. And it can cause your nose and throat to become irritated, and can cause death if inhaled directly. Fuel capsules and how they work. Okay, in the diagram you'll see on the next slide, you can see all the chemical combinations an airplane fuel capsule goes through to create its gas to be able to fly and lift off the ground. First, nitrogen gas and oxygen combined. That then enters the fuel capsule. Inside the fuel capsule, hydrocarbons and sulfur combine as well. The ideal combustion is carbon plus dioxide plus water plus nitrogen gas plus oxygen plus sulfur dioxide. The real combustion is carbon plus water plus nitrogen gas plus oxygen plus sulfur dioxide plus UHC plus carbon monoxide plus carbon soot plus nitrous oxide plus nitrogen dioxide, and that's nitrous oxide plus nitrogen dioxide divided by nitrogen dioxide. And here you see everything that's happening. Nitrogen gas plus oxygen goes into here. The fuel then has hydrocarbons plus sulfur. The ideal combustion, that is carbon plus water plus nitrogen gas plus oxygen plus SOx. The real combustion, CO2 plus H2O plus N2 plus O2 plus SOx plus UHC plus CO plus soot plus NO plus NO2 divided by NO2. And now we have my bibliography. Looks good. Now I just want to hash back on one more thing. How can this affect human health? This is not saying that for every airplane that you ride on, first, let's say you cannot be affected on the airplane itself. Nothing can get to you on the airplane itself. And just because an airplane going overhead doesn't mean you need to go and find a gas mask right away, because most of the time it travels in the jet stream. So it can take a while for it to get to us. So like maybe a day to a week before it can get to us after that airplane has traveled there. So you can imagine it doesn't affect us right away, but with the amount of traveling there is done by airplanes, you can imagine that there's a great amount of pollution from them, as well as airports with all their electricity running. And also one more thing, the facts. That was published by MIT. There was another blog published by somebody that said there are more deaths by pollution from airplanes in the air than there are airplane crashes. And there aren't many airplane crashes, but when there are, they tend to be big and they tend to have a lot of people on them. They tend to be the bigger aircrafts that that have a lot more people on them. So they're the bigger ones, of course. And then methane. Methane is not used in a lot of the airplane fuel that they have for the airplanes. The atmosphere. Scientists only record up to 3,000 feet in the air, because it is said anything above that, the air is very wispy and thin, so it will go away pretty quickly. So they know they don't record anything above 3,000 feet. So the airplane fuel currently has 11% of the United States CO2 emissions. That's a lot just for airplanes. Like factories and other things have it, but just for airplanes to have 11% is a lot. And it's said by 2050, aircrafts are said to gonna contribute to half of the worldwide contribution to climate change are going to be from airplanes and emitting everything. And there we go. That's my bibliography. I hope you guys enjoyed this. Sorry for the shaky camera. But I really hope you guys enjoyed this, and maybe sometime I can do it again.